All right, so we're recording. Not a good start. I'm going to graph this in point slope form. Everything in math kind of has this function where the things that are harder to understand are the ones that are easier to do. So you were saying you don't get how to graph this. So you wanted to try and multiply, you wanted to try and distribute the 3 halves and add a 3 to both sides. So at least you know how to do it that way. You like it that way. But what I'm saying is if you can understand how to do the confusing one, the ones that are confusing are almost always easier to actually do. The process is almost always actually easier. This is in point slope form. The point is -1, 3. It's pretty easy to remember because whatever goes next to the x letter, whatever's here next to the x letter, goes over here. Whatever's here next to the y letter is the y point. So that makes pretty good sense. So I'm going to start with the point -1, 3. From that point, I'm going to do a slope. Emily?
Why is it -1?
It's just how the property works. You just take the opposite of this and the opposite of this.
Oh, you're kidding.
It'll always be the opposite when you're in point slope form. I explained why like a week ago. For now, I'm just trying to memorize the opposite. From this point, I'm going to go up 3, right 2. Up 3, right 2. Up 3, right 2. Down 3, left 2. Down 3, left 2. Down 3, left 2. Remember when you're graphing to put down as many dots across the plane as you can. Now that I've got my dots, graph my line. There it is. Notice how my line goes across the entire plane. Okay, is there a question about that one? Should be okay with that. These next two are the ones that were new, and the ones that I think are going to be more challenging. Number 2 is called an absolute value function. Because of the absolute value lines, I call them a wall. Because of these, I know the graph is going to make a V. The V could point up or it could point down. In this case, it's going to point up, but it could be either one. What you want to do is make a table of values, and you want to put in the middle of your table the number for x that would make this part equal 0. I want to make the stuff inside the wall equal 0. Well, in that case, that's a 3. If I plug a 3 in for x, 3 minus 3 is 0, so I'm going to put a 3 here. It's the middle of my table 3. I'm also going to go up a couple and down a couple. So we're going to go from 1 to 5. Let me try and fix this. If I plug in 3 for x, 3 minus 3 is 0. The absolute value of 0 is 0, plus 2 is 2. If I plug in a 4 for x, 4 minus 3 is 1. Absolute value of 1 is 1, plus 2 is 3. Plug in a 5 for x, 5 minus 3 is 2. Absolute value of 2 is 2, plus 2 is 4. Plug in a 2 for x, 2 minus 3 is -1. The absolute value of -1 is +1. 1 plus 2 is 3. Plug in a 1 for x, -2. Absolute value makes it +2. 2 plus 2 is 4. When I graph these points, I have 1, 4, 2, 3, 3, 2, 4, 3, 5, 4. And there's another V. There's the V. Is there a question about how I did that at all? Yeah.
Are those the next coordinates that you want to use?
It won't always be those 3, those 5. It could be any.
Because I like doing it like -2, -1, 0,
The problem with that is that might not contain your corner, right? If we went from -2 to 2, we would never gotten a corner because -2 to 2 really just graphs like this. Not where I wanted it. -2 to 2 graphs like that. So you're not going to see the corner. You have to keep going, which a lot of people on their homework weren't sure which direction to keep going. So what you want to do ideally is plug 3 in because 3 gets a 0. Whatever gets you a 0 is what goes in the middle. And this is another example of where if you can understand the hard part of making this 0, is easier to graph. Whereas the easier thing is to plug in numbers, that can take forever. Ellie?
I was just wondering how to draw the same.
Okay. And then Riley, your hand's up?
So if you have a sideways one, it's not right.
Correct. These are not going to go sideways and go up and down. If you had a sideways one, you probably switched your x's and your y's. You probably graphed the point 4, 5 when you wanted 5, 4. Probably would happen. Okay, is there a question about number 2? Any other question? That's absolute value. Okay, let's talk about number 3. Number 3 is called a piecewise function. It's piecewise because like the graph is broken up into pieces. The two pieces that I'm going to work with have x where it's less than 1 and x where it's greater than or equal to 2. And I'm going to make a table for both of these pieces. Wow, if that had been like the actual grade book, I would have had to like redo the whole video. So I can't be putting grades online. That's not something in class. 2 tables. One table where x is less than 1, this table goes here. And one where x is greater than 2, this one goes here. I'm going to start with this number. I'm going to start with the 1. I'm going to plug in numbers that are less than 1, like 1, 0, -1. All of those numbers are less than 1. If I plug a 1 into this function, because that's the one that has x less than 1. 1 plus 2 is 3, 0 plus 2 is 2, -1 plus 2 is 1. So I have the point 1, 3, 0, 2, -1, 1. The line's going to go like that. Notice how the line is pointing to the left. And this arrow is pointing to the left. This points left and the line went left. If it pointed right, it would have gone right. What's the one thing that I'm missing here? Alan? Never mind. What's the one thing I'm missing? Luke?
Is it the open close circle?
This needs to be an open circle. It's an open circle because I can't include the point at 2. So this is going to be an open circle. The graph's really going to be like there. Any question about that part? What about this right here? It's just showing the graph's going left. It's just showing the graph goes left. Yeah?
The V one, do we have to do the full graph or can we just like do it like that?
As long as you have like a good chunk of the V, that's fine. I don't need to see all this stuff down here if we're not using it.
Okay.
Yeah, that's fine. As long as you have a good graph, we're good. What numbers should I plug into the second table?
1, 2, just say 1, 2, 3, 4.
I need numbers that are bigger than 2.
Oh.
2, 3, 4.
Oh.
2, 3, 4. So start with the number that's listed, Riley. Start with the number that's listed. 2 came first, so put a 2 first and go up from there. So if I plug in a 2 into this equation now, -2 times 2 is -4, plus 1 is -3. If I plug in a 3, -6 plus 1 is -5. I plug in a 4, -8 plus 1 is -7. So it's 2, -3, 3, -5, 4, -7. This is going to have a closed dot. Yep. Look like this. The 2 red lines put together is the piecewise function. When I put together, I mean combined. Don't move them where their graph is correct. But the 2 red lines make up the piecewise function. Yeah.
You do it the whole way.
Across the plane. Yeah.
So like you, so the mid the intersection of anything.
No. So they stop. They're never going to intersect because this line isn't actually a line. It's a ray. This right here is a ray going to the right. It's not really a line. It has a starting point and goes on.
Oh, okay.
This also has a starting point and goes on. So it's like pieces of lines. That's why it's called a piecewise function. It's a piece of a line. Yes, Sophie?
How do you find like the main line?
Let's not worry about that right now. We can deal with it later. Luke?
Wouldn't technically the line with the open circle be going towards the open circle since you can contain all the points up until...
Technically, yes. It's going to the open circle and stopping. So it's a ray going to the open circle and stopping. Yes. Any other questions? This arrow is pointing to the right. Stop doing that. This arrow is pointing to the right. So the graph moved to the right. Okay. Okay, we'll do 2 more absolute values. When you're making your table of absolute values, the goal is first you want to make inside the wall become 0. That's the goal. You want to make whatever makes the wall become 0 the center of your table. So the easiest way to do that, and you can do this every single time, is take whatever's inside the wall and set it equal to 0. And just solve this equation. I'll add a 6 to both sides. Divide both sides by 3. And I have x equals 2. That means I want 2 in the middle of the table. Because that's what makes the inside of the wall become 0. So I have 2 in the middle of the table. I'm going to go up a couple and down. Yes, Riley? Okay. If I plug a 2 in for x, 6 minus 6 is 0. The absolute value is 0, so that's the point 2, 0. That's where my corner is going to be. Plug in a 3, 9 minus 6 is 3. So 0.03, sorry, 0.33. And I'm also going to have the 0.46. So I'll get a 4, get out of 6. If I plug in a 1, 3 times 1 is 3, minus 6 is negative 3. The absolute value of negative 3 is 3. The absolute value of negative 6 is 6. And the graph's going to look like that. Alright, we okay there? What should I put in the middle of the table for the problem on the right? Yeah, Riley?
Negative 2.5.
How'd you get negative 2.5?
That's the negative of 5 divided by 2.
Yeah, if you take 2x plus 5 and make it equal 0, that's our goal, to make the inside equal 0. Subtract a 5 from both sides. Divide everything by 2. That's what I want in the middle of the table. Negative 5 over 2 is negative 2.5. Yeah?
What would you do with the 3 and the negative?
I just ignore them for now. I just ignore them. Now, what are some numbers that are bigger than negative 2.5? Let's make our life easy. Let's skip negative 1.5 and do negative 2, negative 1, 0. And negative 3, negative 4, negative 5. Let's do those. Nope, this is bigger than this. Greater. Greater. I'd rather have no dollars than owe somebody $2.50. So, Sophie, when I plug this in, so if I plug in negative 2.5, it's negative 2.5 times 2. 5, actually. Negative 5. What's negative 5 plus 5? What's the absolute value of 0? What's 0 times 3? What's 0 minus 1?
Oh wait, negative 1.
That's the point 2.5, negative 1. I can't graph that super well, but it's going to be right about here. Let's plug in negative 2, so it's negative 2 times 2. What's the absolute value of 1? Times 3 minus 1?
You just said 1 minus 1.
3. 3 minus 1.
Oh, 2.
What's the point negative 2, 2? Let's do negative 1 also, so if they only view alone. 2 times negative 1 plus 5.
3.
Absolute value of 3 times 3 minus 1. 8. So that's the point negative 1, 8. Here's half the graph. Bella, can you do the other half? Let's plug in negative 3. Negative 3 times 2. Negative plus 5.
That feel like
Negative 1.
negative 1.
What's the absolute value of negative 1? What's 1 times 3? What's 3 minus 1? 2. So at the point negative 3, 2. If you move on me again. And then the next one's going to be here. That's exactly what happens when you overthink it. Just start doing the math.
That's because I'm not used to
Doing
minus
them.
3 minus 1.
So there's the absolute value. Forms of V, put the 0, put whatever gets a 0 inside the wall, put that in the middle of the table. So negative 2.5 right there. Question about that? Okay. There are two ways to go about piecewise functions. I've talked about how to do it with making a table. And I'll show that again, but I want to show another method also. If you are working on something else right now, I want you to look up here and follow along with this. Okay, great. I want you to just follow this now. One method that I've shown was in making tables. When you make your tables, a table for everything where x is less than negative 2, so that would be negative 2, negative 3, negative 4. Right? You join me up here?
Yeah.
Thank you. And I would also make a table where x is greater than 2, greater or equal to 2, and that'd be things like 2, 3, 4. And you can plug stuff in and get stuff out and graph it that way, and that'll work fine. You can always do it that way. But what I think a lot of you would prefer is to, instead of graphing points, graph lines and then erase the stuff you don't want. Let me show you what I mean. If I think about this as being the line y equals x plus 4. Well, that has a starting value of 4 and a slope of 1. So the graph is going to look like this. That's how the whole entire graph looks. But since this is a piecewise function, I actually only want a piece of the graph. I don't want the whole thing. I know that I only want the graph when x is less than negative 2. Well, this right here is the line x equals negative 2. This is where x is negative 2. So I only want the graph when it starts here and then moves to the left. I only want the piece of the graph starting at this open circle and moving left. So I'm going to take the rest of the graph and erase it. And you can't erase as well as I can, but you can still basically erase. So I can grab this and erase it until there. That's the first piece of the piecewise function that I want. I can think about graphing the whole line and then erasing the stuff I don't want. Let me show you the other one. We'll do it in red. This is the line y equals 3/4 x plus 1. Well, my starting value is 1. I go up 3, right 4. So I'll go down 3, left 4. And I'll graph this line. Riley, I can hear you talking even though I'm not looking at you. And even though you're talking very, very quietly, I know you're whispering and I know you're not paying attention.
I think my stomach because it keeps growling.
No, that was your voice. I heard the whispers. Yeah, I heard that too. Stop. I want when x is greater than 2. Well, x equals 2 happens right here. That's where x equals 2, on that line. So my starting value is here, and this time I'm going to the right. So I'm going to erase everything over here. That, yeah. Graph goes like that. And those are the two pieces of my piecewise function. I don't really need to have all this stuff anymore, or this, or any of this. And that's how the piecewise function works. Okay, I don't care how you do this. I don't care if you plug in points to a table and plot them. I don't care if you graph lines and erase them. I don't care at all how you go about your graphing. As long as you end up with a picture that looks like this. Is there a question about that at all? You'll note that every single line that we draw is passing the vertical line test. I could draw a vertical line anywhere. And at no point does this vertical line, that kind of works, at no point does this vertical line hit the graph more than once. Crosses here, or here, or here. If you're doing a piecewise function or an absolute value function that doesn't pass the vertical line test, you've done something wrong. It's the first best sign that you've done something wrong somewhere. I'll show another way of illustrating that. We'll come back to that slide. This is a piecewise function that I've already graphed. Here's the black piece, y equals negative x. Here's the red piece, y equals 4. This piece is just the part that we're showing of a whole invisible line that we've erased. And the black piece is just the piece that we're showing of the whole invisible line that we've erased. And if I draw a vertical line, if I think about just the regular graph that I had, if I draw a vertical line, it only hits the graph once. It feels like it's hitting it here twice, but that's an open circle. I'm not actually hitting it. I'm passing through the open circle. So that's passing my vertical line test. Okay, question there at all? Yeah? Yeah, of the graph you've drawn. If it hits the graph more than once, any vertical line hits the graph more than once, it's not a function. And that's a bad thing. It's a problem. You've done something wrong.